Okay, so let's review our code to see if there's any improvements we can make. Now, if we kind of look through our code, while swapped, so we do this over and over again, right? And what we do actually is we loop over the list over and over and over again. And we loop over the entire length of the list over and over again, even if we've already sorted part of the numbers. So what I want to do is shortcut that, and that's an improvement that we can make. So what I need to do is, every time we get to the end of this, what I want to do is reduce the length of the list that we're looking at. It's sort of like in binary search when we had those windows where the window, of unsorted elements gets smaller and smaller each time, right? So, so what we need to keep track of here is the last unsorted index, right? And that's going to be the length of our list, our nums list, to start, right? So we can just kind of replace where it says length of nums. And we'll just run our test to make sure that our code's still working. We haven't messed it up. Cool. Okay. So now down here is when we want to reduce that. And we want to do it at the end of this for loop. So once this for loop is finished running, it's right here. And so what I'm going to do is last unsorted index equals last unsorted index minus 1. And so I'm going to run these tests again just to make sure that that still works. So this is a better performing algorithm because we're checking fewer and fewer elements each time. So if our input was 4 or 5, it wouldn't really significantly speed it up. But if our input had 100,000 elements, it would be a lot fewer traversals to just sort of cut off at the end there. So yeah, that's how I like to think about it. So that's one of the improvements that we can make to this algorithm. Because we have to return swaps, and it does have to be the bubble sort algorithm, there's no more improvements that we can make to the algorithm itself. This is sort of the end, because you have to count the number of swaps, so there's no shortcut really there. Okay, so let's look at the next sorting algorithm in the next video.